Okay, the last chapter, chapter 20, is on inverse trigonometric relations, which you've probably done before, and they're on your calculator. They usually are written like to the -1 because that's what an inverse means. However, that gets really confusing because usually, like if we write x to the -1, that's the same thing as 1 over x. That's how powers work. Negative powers means in the bottom. However, inverse of sine -1 of x is not the same thing as 1 over sine of x. 1 over sine of x is the same thing as, let's see, there's a co in every pair, so it's not secant, it's cosecant. That's cosecant of x. Instead, this -1 means the inverse function, which means it cancels out the sine function. So if we take the inverse sine of x, right, that cancels it out, and that's just equal to x. So that's what they mean by inverse, not 1 over. It's bad notation, it's confusing, it's whoever made up this notation. It's kind of like two different things where the -1 means. It can mean 1 over it, or it can mean a function that cancels out the original function, which is what this means here. So for instance, let's say that we know that the sine of x is equal to 0.5. So what is x, right? We want to find x. We know its sine is 0.5, so we take the inverse of both sides. So we take inverse sine of x is equal to the inverse sine of 0.5. Sine and inverse sine cancel. So on this side we're left with x. And on the other side we plug into your calculator and you go inverse sine of 0.5. And in other words, what angle gives a sine of 0.5? So we always draw a unit circle. So here's our circle here. And we want to know where the sine, which is the y value, right? Sine is up and down, where it's 0.5. So here's a y value of 0.5. So right there is a place. But there's another one. There's another one over here. And what is the y value? When the y value is 0.5, what angle is it? And you should remember that it turns out that that angle is 30 degrees because the opposite then is half of the hypotenuse when it's 30 degrees, or it's 0.5. So if your calculator's in degree mode, you'll get 30 degrees. If your calculator is in radian mode, then you get pi over 6, right? Because pi is like 180 degrees, and 180 divided by 6 is 30. So we know we did that right. Okay, so that's one thing to be careful of. Inverse sine is not 1 over sine, it's the function that gives us that. Now here's the problem. This is the major problem with inverse functions. We know there's two answers, right? We could get 30 degrees, but we could get this one over here. And what is that answer? It's a perfectly good answer. It's also where sine is 1/2. Let's see, that one is pi. This is pi right here. And this is pi minus pi over 6. Let's do everything in radians. We could do it in degrees. We can do both. So pi minus pi over 6. So the other angle is pi 180 degrees minus pi over 6. So we go backwards pi over 6, which is what? This is 6 pi over 6 minus 1 pi over 6. That's 5 pi over 6. That's also a perfectly good answer. Or if we want to do it in degrees, 180 degrees minus 30 degrees, which is 150 degrees. Those are also answers. We can get two answers out. Actually, we can get an infinite number of answers because we can always add 2 pi to each of those answers. So an equally good answer would be 5 pi over 6 plus 2 pi, or plus 4 pi, or plus 6 pi, or minus 2 pi, so we can put an n. Or our original answer, pi over 6 plus 2 pi n, where n is -2, -1, 0, and are the integers. So we have an infinite number of answers, but functions aren't allowed to return infinite number. To be a proper function, you can only have one answer. Okay, and that's why your calculator only spits out one answer. Problem is, sometimes you want both of them. The calculator will spit out the simplest one, but sometimes we want both of them. And so they call that the symmetry solution. So the symmetry solution is the other one that your calculator doesn't tell you, and it's symmetric, right? As you can draw a symmetric picture, and that's that one right there, which we said is 5 pi over 6. They call that's what we call the symmetry solution, and you kind of have to figure that one out. There's ways to figure it out. You can write down formulas for it. I just always draw the unit circle because it makes sense. You don't have to memorize anything if you draw the unit circle. It's really quick and easy to do. You have time to do it in a test, or have it already drawn in your test or whatever, on a cheat sheet or something. But the point is, there's two answers. Calculators only give you one, and that's a problem. Now the nice thing is there are 6 trigonometric functions, but no one ever uses inverse cotangent, inverse secant, because you don't need to. You can always relate things with this inverse sine, inverse cosine, and inverse tangent. Those are the 3 that are most useful. Okay, so let's say we have our inverse sine then. It can only spit out one answer. So the inverse sine of x, the answer it's going to spit out is the angle in between negative pi over 2. So basically we want to get all the y values, right? So all the y values, we got to go all the way from 1 to negative 1. So what they decide to do is go negative angles, so we can go all the way from here, negative pi over 2 to pi over 2. Okay, that's where the range can be. So it always goes from negative pi over 2 to pi over 2. So the answer your calculator spits out will always be between negative pi over 2 to pi over 2, and I should put a bracket because it includes those. Okay, so those are the numbers that your calculator will give you when you do inverse sine of something, which of course is the same thing as what's negative 90 degrees. So negative 90 to 90 degrees. Those are the numbers that your calculator is going to tell you the answer is. And it's not going to tell you the ones on the other side. You have to figure those out, the symmetry solution. If one answer is here, it's over here. If one answer is here, it's over here. You have to figure those out. Cosine, to get the full range, I don't know why I put a parentheses there. Cosine, to get the full range, it's going to spit out, that's the x value. Cosine's the x value. So we want to go from 1 to negative 1. So it goes from 0, right? 0 is 1, all the way to 180 degrees or pi, which gives us negative 1. So its range is from 0 to pi, which is the same thing as 0 to 180 degrees if you have your calculator in degree mode. Those are the different answers for cosine. And then tangent, inverse tangent of x, the answers you're going to get from tangent. Tangent goes from 0. Tangent is the opposite over the adjacent, or sine over cosine. We can just divide these two. It goes from 0 here, because there's no opposite, all the way to infinity. Okay, from 0 to infinity. But if we start over here, cosine can go, or let's say down here, tangent can go from 0 to negative infinity, because the opposite, the adjacent is always positive. If we go from here to here, adjacent's always positive. Stay on this side, that's the x, that's the cosine value. But the opposite's negative down here. So to get the full range from negative infinity to negative infinity and all the way to positive infinity, we need to, what they do is they decide to have these angles, and so it goes from negative pi over 2 down here, and then it ranges all the way up to here to pi over 2. Those are the answers that your calculator will spit out, which of course is negative 90 degrees to regular 90 degrees. So they have 3 different ranges, so that your calculator only spits out one of the answers. But there's always the answer on the other side of the circle, and there's infinite answers, because we can go around 2 pi, 2 pi, 2 pi, because this is, they call them circular functions. We can keep going around the circle. When you graph the functions, right, they go on forever. But the inverse functions can only spit out one thing. So they're limited to that. So that's the tricky part, is finding the other one, because your calculator will only give you one of them. You have to figure out what the other one is. And again, the best way is just to draw the circle and look at it and figure out by symmetry, that's what I call it, the symmetry solution, what that is. So that's the basic idea here. Chapter number 20.1, the first problem, is basically a calculator problem. So they just say get used to using your calculator for inverse functions. So they say if x is 0.1, So like part A1 here, they say, so you want to figure out what is inverse sine of 0.1. If you have your calculator in radian modes, it'll tell you what angle in radians gives you a sine of 0.1. And then you put your calculator in degree modes and you find out what those degrees are. You could just get the answers in this part, change the radians to degrees, but the point is to just practice using your calculator. Okay, and then like part C here, they say find 4 values of x to satisfy the equation 5. So let's say let's satisfy this equation: 5 times the sine of 2x squared plus x minus 1 equals 2. We want to find 4 values, yes, they say 4 values of x that make this true. Okay, so let's see. First, we want to solve for x here. So we're going to put the 5 over there, and I'm going to run out of paper, but oh well. So sine of 2x squared plus x minus 1 equals 2/5. And I need another piece of paper. Okay, so now, let's see. Now we take the inverse sine of both sides to get rid of this sine over here, because we want to get this by itself. So then we have, after we do that, inverse sine of sine cancels, that's why we do it. So 2x squared plus x minus 1, well, that's a bad plus sign, plus x minus 1 equals inverse sine of 2/5. Okay, well, what is the inverse sine of 2/5? Here we just have a nice thing here. So here we just have our 2x squared plus x minus 1. What is the inverse sine of 2/5? So you plug in your calculator. 2, and you go inverse sine, and my calculator spits out 0.4115. 0.4115. Okay, now if we solve this, we're going to get maybe 2 answers because we get a plus or minus. They want 4 answers. So again, this is going to be a quadratic formula problem. But again, this is going to give us 2 answers, right? We're going to get a plus or minus. We use a quadratic formula, we get a plus or minus. But they want 4, and that's because there's an infinite number of answers. So here's the idea. Again, you draw your unit circle. It's my unit circle. We want the sine to be equal to 2/5, right? That's our original equation. When is a sine equal to 2/5? Well, that's 2/5 is 0.4, a little less than a half. So this is a unit circle, so this is 1, so here's 0.5, so 0.4 is right about there. And then they told us that, okay, that angle there is 0.4115 radians, because that's what I'm doing this in. So 0.4115 radians, because my calculator was in radians, so this is 0.4115 radians. Okay, but there's also this answer over here. Or we could add 2 pi to that, or 2 pi to that, or 2 pi to that. So we have an infinite number of answers that can solve this thing. They say to get 4. Okay, so we can solve it now, we get 2. But let's choose another one here. Again, we can take 0.415 and add 2 pi. So we can solve this equation, and then we can also solve the equation 2x squared plus x minus 1 equals 0.4115 plus 2 pi. Or we could add 4 pi, or we could go minus 2 pi. So I could put an n here, and you can choose whatever n you like. So there's an infinite number of answers to this. That's why they don't even put answers, I don't think, because there's so many you could choose. Now that's one way to do it, or we could take our symmetry solution and add 2 pi into that. Okay, so what is the symmetry solution? It's 1 pi, which is right here, minus 0.4115. So we could also solve 2x squared plus x minus 1 equals pi minus 0.4115. That's this angle here now, right? Pi minus that's the symmetry solution, plus 2 pi n. So plus 2 pi n, where we can choose any n we want now, and n can be 0, that's the simplest one, and n can be -1, we can subtract 2 pi. So again, these are all the solutions. Now we have every single one, every single equation possible, infinite number, we want to choose just 2, choose the simplest ones. If there is a simplest one, maybe 0.4115, and then add 2 pi. Again, there's an infinite number of solutions. You're going to have to use a quadratic formula. That'll give you 2. So then you just need to do it twice. Okay, so that's the idea. Kind of tricky. You know, there's an infinite number, but they just kind of want you to see that. And the part D is the same. Okay, let's look at 20.2 now. So 20.2, let's look at C. Let's do C because it's probably a tricky one. They say f of x is the sine of 2x minus 1, and g of x is equal to 1/4. And they want us to graph these things and find the principal and symmetry solutions. The principal solution is what your calculator tells you. That's this one. Okay, the symmetry solution would be this one, is the other one over here, is the simplest ones, right? And then all the other solutions are the 2 pi n's, so you can go around the circle. But if we don't go around the circle multiple times, if we go to the first one here and the one over here, they can be down here and over here. But that's the idea. There are single answers for principal and symmetry. Principal is what your calculator tells you. Symmetry is the one on the other side. Okay, so sine of 2x minus 1. They want us to graph this. Okay, we figured out before the way to graph something is to draw it in standard form. Makes it a lot easier. 1/4 is easy, right? That's just a horizontal line. But let's write sine of 2x minus 1 in standard form. And to remind you, standard form is y is equal to a sine 2 pi over b x minus c plus d. Okay, d is 0. The average is 0 here, right? There's no plus over here. A is 1, so that's easy. So it's like a normal sine wave, but it's going to be shifted. So let's write that again. So our y is equal to sine, we want to get the x by itself, so 2 times x minus 1/2, right? Because then we always check. 2 times x is 2x. 2 times negative 1/2 is negative 1, which gives us a sine of 2x minus 1. Okay, that's right. So let's see. Our c is 1/2. And oh, now we got to write our period. So 2, we want that to be 2 pi over b. Because so we set, and there's other ways to think about it. I just don't like to think. I just set 2 equal 2 pi over b. So, I mean, I like to think sometimes 2, but it's easiest to say we want 2 to be 2 pi over b, so what's b? So 2 is equal to 2 pi over b. We can swap the 2 and the b, so b is equal to 2 pi over 2, which is pi. So our period in this wave is pi. So finally we have y is equal to sine of 2 pi over pi, which clearly works, right? 2 pi over pi is 2, which is there. We could have seen that right away. If you're clever. I'm not that clever. X minus 1/2. That's our sine wave. Period of pi, and it's shifted 1/2 to the right. Okay, so now they want us to graph this. So again, you can draw a reasonable graph without graph paper. Graph paper helps. I'm going to start at 0, but we can go negative. Okay, period of pi, but it starts at 1/2. So let's do 1/2 here. Okay, let's put the axes here. Period of pi. So let's put pi over 2, and then pi, and then 3 pi over 2, and then 2 pi, period of pi. So it starts at 1/2. Pi over 2 is the same as 3.14 divided by 2, 1.57. 1.57. Our wave starts at 1/2, which is about 1/3 of that, so like right there. And remember, sine where they start is where they start going up, and the period is pi. So I add pi to that, so it's going to be always a little bit more than pi. It's going to be a little bit more than 2 pi. And halfway in between, and we could figure out the numbers, but I don't need to. I'm just going to guess. It's also going to hit here. And it's going to go up to 1 because its amplitude is 1 down to -1. And it's going to hit, the story starts going up. So it goes like this, goes like that. It's going to be halfway in between. It's right there. Goes like this, goes like that. See, halfway in between is here, halfway in between those is here, here. So it goes up there, down, and it keeps going forever, and it kept going this way forever too. Okay, so there's our rough graph of this thing. Now, when does it equal to period of pi? We want it to be equal to 1/4. So there's 1, here's a half, here's a fourth. So we draw a horizontal line here, 1/4. Okay, so all our solutions are this one and this one. And then we have this one and this one and this one. And it goes on forever in this one, and we have the negative solutions, right? We have over here, we could say right here and right here. There's an infinite number of solutions. That's the 2 pi n part. This is sine. For sine, the symmetry solutions are always between pi over 2 and negative pi over 2. So actually our symmetry solution, this is the first one, the closest one, and the other one is over here. Because it's always, this one is always the positive one, and the negative one would be the other solution. So anyway, infinite number of solutions you can find. And yep, so that's, if they ask you to find all the places it's infinite, you can use the 2 pi n thing. Yep, so that's kind of the idea with these. If they give you a cosine, you should change it to sine. Well, you don't have to, but that's one way to do it too, to write it in standard form, is to change it to sine. Okay, so that's the idea here. Yeah, that's how you do these. It's pretty tricky because of the whole symmetry solution thing, only one possible answer. Again, I find it really, really helpful to draw a unit circle. That really helps you think about these things. Yeah, okay, speaking of that, this is graphically solving it. Okay, let's actually solve it now. So we have sine of 2x minus 1. We want that to equal 1/4. So sine of 2x minus 1 equals 1/4. Take the inverse sine of both sides. 2x minus 1 equals inverse sine of 1/4. Plug that into your calculator. 0.25 is it? I'm in radian mode, so I get 0.2527. And of course it goes on forever, but 0.2527 is good enough. Sine of 1/4. Okay, so what that means is that, let's draw a unit circle now. So we want sine of something is 1/4. 1/4 is right here. Okay, so here's our symmetry solution. Here's the symmetry solution, and here's the regular solution. So that angle and that angle. Well, the calculator told us this angle right here. My circle's too small to write it there, but that's 0.2527. So the symmetry solution is the other angle, which is all the way to here. Okay, and that's going to be pi minus 0.2527. So pi minus 0.2527. Since we're decimalizing, you might as well decimalize that. So I get 2.888, so 2.889, let's say. So this is equal to 2.889. And we know that it can be that answer plus 2 pi n, plus 2 pi n, plus 2 pi n. So really, as soon as we write this, when we write down one answer, that's the first answer. You know, really, there's infinite. It can be plus 2 pi n. Or it can be the symmetry solution, 2.889 plus 2 pi n, because it can be this one plus go around the circle plus go around the circle. So we have two possible solutions for 2x minus 1. What do we choose? There's an infinite number of ones, right? Typically we choose the symmetry ones where n is 0. Okay, n is 0. So what we have to do to solve this then is choose n equals 0, which means we have 2x minus 1 equals this first one. This is the regular solution, the one your calculator spits out. Okay, 2x minus 1 equals that. And then we also have the equation 2x minus 1 equals a symmetry solution, which is 2.889. 2.889, and we solve for what x can be here. What are the possible values of x? And the answers we get will be the ones on our graph, will be these dots we put where 1/4 hits this sine wave. And this is easy math, right? Solving for x, that's not hard to do. But that's the idea here. Okay, and again, there's infinite numbers because there are infinite numbers. There's an infinite number of points in the graph where it hits both positive, or we can go in the negative direction too. Lots of values of x, lots of values for x. There's one answer for x. Here's one, here's one, here's one, here's one, right? Lots and lots of values for x that make this work. The principal ones, the ones that we're going to find here, let's see here, okay, let's just do this really quick. So 2x is equal to 1.2527, x is equal to half of that, so 1.2527 divided by 2, which I get 0.62635. That's going to be this one right here. Okay, that's the first one. And then the other one is 2x is equal to, add 1 again to this side, 3.889. X is that divided by 2. 3.889 divided by 2. It's 1.9445. And that's going to be this one. I think I said that one before, but I misspoke. Obviously, that's wrong. There's two solutions. This is the principal right here, principal solution, and then this one is the symmetry solution, and all the other ones are the 2 pi n solutions because there's infinite. But those are the two main ones on each side of the curve. Okay, that's how you do these. They're pretty tricky. This whole chapter is using what you learned last chapter, but now using inverse sine we can find more points on sine curves and stuff to answer questions. So okay, hope you followed all the way through. Thanks for listening, and good luck in these problems.